Okay, so open addressing, what does this do? It has three kinds, which are linear probing, quadratic probing, and double hashing. So it's like it sequentially searches for an open slot until one is found. So what do we do? First, we convert the key to an index by using mod with the hash table size, that is k mod m is equals to that index value, and if there is already a key at that index value and we have to place another one, then collision happens. So to avoid that, the next key that we have to place, which is actually pointed to that same slot as another key, we just sequentially search for the next possible open slot that we can put this new hash value in. So the math formula is like h of k plus I mod m. So k mod m ki h of k plus I mod m. I think this is k. This is not. Yeah, this is k. So what's going on? K is the key and I is the looping variable. I will tell you why we need this looping variable in the example. So I have taken 5 numbers 93, 94, 79, 83, 33. So observing this, we will assume that 93 and 83 and 33 will have the same positions, and 94, 79 have separate. So actually we have to find this sequentially. So 93 mod 10 is equals to 3, I have put this here. 94 mod 10 is equals to 4, I put this here. 79 mod 10 is equals to 9, I put this here. Now 83 mod 10 is equals to 3, here collision occurs. So what do? I have set the looping variable kada. First assume it to be 1. 83 plus 1 mod 10. I'm getting 484 mod 10 kada 4, but at 4 there is already 94. So I increment the looping variable. 83 plus 2 mod 10 equal to, now I get 5. Okay, so I put 83 at the slot 5. Like that we do for 33, and I have placed it at slot 6. So it sequentially checks the next open slot which is available. Now quadratic probing is the same thing. But instead of I, we put I square. That's the only difference. Okay, and yeah, so double hashing. So there are two important rules to follow. It must never evaluate to 0. So we are going to perform an operation between two hashing functions, and we will resolve the collision using that operation. Okay, so the two important rules are, it must never evaluate to 0 the operation, and the second hash function must be relatively prime to hash size. I will explain what this means now. Okay, so h of k, h1, the first hash function, will be obviously k mod m. H of 2 will be n minus k mod n. So it's like k mod n, then we subtract it from n. So n is what? The prime number, the highest prime number less than m. Highest or maximum prime number which is less than m. For example, if our hash table size is 10, then the highest or maximum prime number less than 10 will be 7. Okay, so that will be our n. So second hash function must be relatively prime to the hash size. That is what this means. Now if h of 2 is also not still collision is occurring, h of 3 is equals to h1k plus I into h2k mod m. Okay, so when this fails, you just increment the looping variable and you get the index values accordingly. So I'm doing this 3, 22, 27, 40, 42, 11, 19. So for the first few values I have got positions. Now 22 is already placed at index 2 and I want to add 42. So what do I do? 42 mod 10 is equals to 2. This is H1 and collision occurs. Now I do H2. How do I do it? Since table size is 10, n is 7. 7 minus 42 mod 7. 7 6 are 42, so it's 0. 7 minus 0 is equals to 7. But at 7 we already have 27. So still here collision occurs. Now I do H3, hash 3. So H1k, which is 2, plus I have taken it as 1, H2k, which is 7. So 2 plus 7 mod 10, I have taken it as 9. And at 9th location I am placing 42. Better to write that 42 is placed at index 9, or insert 42 at location 9. Okay. So here 19 I have got, and 19 is already 42 is already placed at 9, so I cannot place 19. So accordingly I will do this h of 3 also, it's like 1, but 11 is at 1. Here I did this 11, so it's at 1. So I just multiply the looping variable. Since it's 1, here it's 2, and then I get at 3, here also collision occurs. Then I get 5. Then I insert 19 at 5. Okay, so what is a cluster? Cluster ante if they're like numbers which are fitting in the same location, that whole bunch of numbers is called as a cluster.